Kotlin is the new star among the programming languages, and that's why we are here together today to learn a bit of Kotlin. I have to put a bit of a disclaimer before this. We have 3 hours for the entire session. We can't put every little detail of Kotlin into 3 hours. That compression has logically to be a lossy compression because Kotlin is really an amazing but also huge programming language. So we will have to take shortcuts here and there, but I hope you will still get a lot out of this session. And in case you got a lot out of this session, but it's not enough for you and your organization, you can always also approach me. I have a huge training catalog on various topics that I do for companies: test-driven development, Kotlin, Java, behavior-driven development, clean code, refactoring, design patterns, also cloud technologies like Docker, Kubernetes, Terraform, and so on. So in case you say, cool stuff, I want to use it in my organization, but we need more than just a 3 hours meetup. Can you train my team? Just approach me. Okay, let's dive to the next and last slide, which is this one. And by the way, you can see my presentation on 2 of the channels of the meetup, the Meet call. And depending on your bandwidth, you can choose whether you want to see me in front of the slide, that is my shared camera, or you want to see the screen alone, that is the shared presentation. Depending on the bandwidth, one or the other is better for you. You can just choose what works best for you. This is a famous quote from Linus Torvalds, the creator of Linux and Git. Talk is cheap, show me the code, and that's what we're going to do for the rest of the session. We're going to look into Kotlin code, and most of the time I'm going to compare Kotlin with Java. Now, if you don't know Java, that's fine. We're not going to go into a level of detail where you really must be a Java crack or a Java freak. General programming skills will be sufficient. Okay, and I'm also showing you how I'm going to start this project and its code. I have a nice GitHub template. It's not specific to Kotlin. It's a generic template, more like a Java template. And that's what I'm going to use.
One quick recommendation to all the participants. You can also maximize your own screen size. When you click on the 3 dots, you have that option of full screen. So you can turn your screen to full screen in order to see if you're unable to see it very clearly. Yeah, you can go ahead and do that. Another thing is we're recording this session. I'm putting that in the chat as well. And Christian, you can also maybe maximize your screen size, and the code font you can make it slightly bigger when you're showing the code.
Yeah, that's what I'm gonna do.
All right.
Okay, so we have the repo. So cloning the repo. That's an empty repository. It's for now just a Java repository. And that's what I'm gonna open in IntelliJ IDEA. There it is. While it's important, I'm going to tell you a little bit about Kotlin. The reasons why Kotlin is totally superior to Java. Totally superior is a phrase that I rarely use between programming languages. I wouldn't, for example, even say this about C++ in comparison with C. I would not call C++ totally superior to C, because there are platforms for which you definitely want to develop in C and not C++, simply because there's no C++ compiler available, or because programming in C++ will just not fit in your memory. You know, like if you develop smart cards, for example, the smaller devices, they still just have like 4 or 8 or 9 kilobytes of RAM. You're certainly not going to use C++ on such a platform. The phrase totally superior when comparing programming languages is a phrase that should be used with a lot of caution. In comparison, Kotlin versus Java, this phrase is definitely justified. And if you're a Java developer, you're going to see throughout the presentation why that is the case. Right, so let's start with a little bit about setup. I have a Gradle project here that is empty, and this is a Java Gradle project setup. So Gradle is the build tool that we, one of the build tools that's very popular to build projects on the JVM. There are five popular build tools on the JVM. GNU-make, that's mostly used if you have a low-level build and if you involve also C code. The Java virtual machine is written or built with GNU-make. Then you have Ant, that is for some low-level projects still the build tool of choice. Then you have Maven. If you are masochistic and you want bad XML to be in your project, then you use Maven. If you saw the light and you want to be less masochistic about your project setup, you're using Gradle. That's also the default build tool kind of for Android Studio. Automatically, if you don't tell it anything different, it's going to use Gradle as your build tool. And then if you're more in the Scala world, or if you use Play as a framework, then the build tool that you use will typically be SBT. And if you've used other build tools and then you use SBT, you start hating SBT and you wish you've never started with it because it's so slow. We are using Gradle here as a build tool. And I could already make the changes that turn this into a Kotlin project. But the first thing I want to show you is, if you are a Java developer, how easy it is to go from Java to Kotlin. In this case, I'm not gonna do TDD. I'm just gonna do some direct code. Yeah. And by the way, what Mayank said in the beginning, if you have questions or if you have remarks or so, don't hesitate. Just unmute yourself and speak away. So create a new Java class, Kotlin.flow.
By the way, Christian, some people might post the question on the chat rather than asking them directly. They can probably put that on the chat as well. So you can probably keep looking at the chat window just in case someone has a question. Like, for example, someone who has asked a question.
Yes. There was a question about Groovy, for example. I see this Groovy question. I think the main benefit of Kotlin over Groovy is that Kotlin just gained a significantly bigger momentum. And that, but Kotlin is definitely also a lot inspired by Groovy. If you're a Groovy developer, yeah, if you start Java, Yeah, JVM, cool, libraries, cool, language, something's good, something's not good, too stiff, then you will also feel quite familiar and quite home at Kotlin. So let's just write a hello world. I think there's something in my project setup missing. Probably no JDK selected. Or it defaults to Haskell somehow. So let's choose JDK 15. And then the red things should disappear on the screen. Yep. Let's just try if this works. That's obviously not Kotlin, yeah? That's right now Java code. But I want to show you how easy it is to convert Java code to Kotlin. If you have IntelliJ IDEA or Android Studio, you hit Control-Alt-Shift-K, and then this dialog appears. It says, well, Kotlin isn't configured in the project. Okay, configure Kotlin in the project. What Kotlin version do you want? Yes, we want 1.4.10. That is the latest version. And for all modules, we only have one module in this project anyway. And it has just updated the project configuration and added this plugin to my Gradle build, the Kotlin plugin. And that's basically what it's done. And it's added the Kotlin standard library to my project configuration. So now I can use Kotlin, reload my project configuration, and then I use the same keyboard shortcut again. Once Gradle is done here, I have to wait for Gradle import to finish. Okay, now it's done. And then it converts Java to Kotlin. And ta-da, that's the converted code. We're not going to go into details right away. First thing I wanted to show you is how easy it is to convert code in a project from Java to Kotlin. You have IDE support for that. It's largely automated. It doesn't always work perfectly well. This example was simple, so it worked. It doesn't always work perfectly well. Sometimes you have to tweak the code a little bit. Even in this case, I actually want to tweak the code a bit. But that's really great support in a project. And then I can say, okay, I don't need this to be in a singleton object. I can make this a top-level function. Kotlin supports top-level functions. Functions are first-class citizens. And the main signature is overloaded. If you don't use arguments, you don't need to declare them. And that is the final hello world in Kotlin. Just that, press the wrong button. I have to use this one. Okay, and that's the working hello world. Now, if you compare it with Java, what we have so far is, you see, we have the same hierarchical concept, how we structure projects, the same directory, tree, and hierarchy, and the same set of keywords, at least some of them. We have the package keyword. You can see no semicolons. Semicolons are optional in Kotlin, which I think is great progress. I never had problems with the semicolons in languages like C or C++ or Java. Because when I look at my Java code and I remove all semicolons, it's still entirely clear what the code means. So they're kind of redundant. They're kind of a compiler legacy from the 70s. And Kotlin did away with that. Next thing I want to show you is the interaction between Kotlin code and Java code. Can you actually call Kotlin from Java? Can you call Java from Kotlin? And how do you structure your directories for mixed code? So I'm going to introduce a new Java class. Oh, that was the wrong one. Now I have a Java class named hello, and I have a Kotlin file named hello, and that's completely fine. The Kotlin file named hello will actually compile into a Java class called hello KT. And here I could also just say hello.main. And I'm going to change my signature here to use bar arcs, so that I don't have to pass an empty array. And that's Kotlin code calling Java code in the same project. We run it and it works just fine. Yeah, the hello world is now printed by the Java code. We can also do this the other way around. I have my print line in the Kotlin code and have my Java code call Kotlin. And again, works just fine. So the interoperability between Kotlin and your other language, in this case Java, is really very, very nice. This allows you to transit projects gradually from Java to Kotlin. It also allows you to say there are pieces of code which you prefer to write in Kotlin, but you don't want to transform the entire project to Kotlin. Yeah? This can also be a valid or legitimate approach. Mixing the languages is easy. The JVM is, by the way, not the only platform that's supported by Kotlin, and that's something that not only makes Kotlin as a language superior to Java, but also as an execution environment. There's also Kotlin for JavaScript. There's Kotlin native. You can compile Kotlin to direct binaries. And there is Kotlin for iOS, which means that you can really do cross-platform development in Kotlin. You can do front-end development, back-end development, standalone applications, Android and iOS in Kotlin. Yeah, it becomes a one-fits-all language. And that is something that puts Kotlin ahead not only of Java, compared to which is really the better language. At Nerkinder, we are migrating all our projects to Java. We've completed the migration of all our active projects. And in the next 2 months, we're going to migrate our frozen projects, the ones from the freezer. It's really the superior language. But you can also write more reusable code. You can write libraries that you can use in the backend and the front end. Yeah, for example, validation is such a topic that we always duplicate for good reasons between backend and front end. Yeah, the backend has to validate for correctness and robustness and security, and the front end has to validate for user experience. You don't want the round trip to the backend to tell you that your input is wrong. You want to see that your input is right or wrong while you're typing. So code we typically write twice. Now you can just write it once. Of course, you could also write it once if your backend was Node.js. So that's the hello world and the interaction.
Yeah, Christian, before you move forward, there could be some questions around on the chat. Maybe you can answer them. Puneet and
okay. So, yep, I see one question is, how does Kotlin compare to Scala, especially in case you want to use functional programming and want to leverage functional libraries like cats? Now, I don't know the cats library. I can't comment on that. But Kotlin is a paragon of multi-paradigm done right and done well. Kotlin supports all the major programming paradigms. Yeah? Structured programming, no go-to. That's kind of almost 100% enforced. I mean, you have those go-tos in disguise that in Java they are break, continue, early return, and throw. You still have them in Kotlin, but you don't have a real go-to. You have proper object-oriented programming, which in Kotlin actually is nicer than in Java for a number of reasons, to which I'm gonna come. But functional programming in Kotlin is significantly nicer than in Java. Now, if you are on the track of academic functional programming, then Scala feels nicer with its type system. But in a lot of situations, you actually don't really need the type system of Scala to be the way it is. You can be more pragmatic. And if a pragmatic approach to functional programming, if you just want it to work and make your code beautiful, if that is your goal of functional programming, then Kotlin works really very, very well. We are going to see that. The next question, Vishal asks, as this function in Hello KT and there is no class we have defined, is it still a public static kind of function like Java? Very good question. Let's go to Hello KT. Yes. We can actually really look into this, so that you can not only listen to me and I could tell you anything. I could tell you a story of a dead horse. I can really show you that this is the case. Java p minus c minus cp build classes Kotlin main Kinder Kotlin Hello KT. Oh, that was I sneaked in, and you can see how the Java virtual machine sees this piece of Kotlin code. You see that there is a final class Hello KT, and that this final class Hello KT contains a public static final void main method with exactly the signature as specified in Kotlin, with the code where you see this print line directly maps to the print line from system out. There's no disguised call or so. We're gonna see in a while how Kotlin does that. And we have an overloaded main method with the string array. That's the signature the JVM expects, which is simply calling the others, and they are static. I hope that answers your question, Vishal. Then next one, yes, that's also an answer. Is it mandatory to give KT suffix while calling Kotlin class from Java? That is only for those Kotlin classes that you don't see in the Kotlin code. If you look at the file on the screen, for Kotlin, main is a top-level function, and the JVM simply doesn't have top-level functions. The JVM needs each function to be in a class. So when you have file scope declarations in Kotlin that are not classes or interfaces or things like that, and they generate symbols that have to be accessible by the JVM, then the Kotlin compiler will create a class taking the file name and appending KT. Like in this case, Hello KT. It's only for those Kotlin files where you have top-level declarations. I can make, for example, a Kotlin class named point. Make it a data class and say we have a val x int and a val y int. Now we don't have anything else here right now. If I compile this class, the class name will be point. It will not be point kt. It will be point because the name of the class is visible in the file. I hope that answers the question about the kt suffix. Then, can we name the Kotlin class with only the main function differently? So you mean you want this to have a different name? Yeah. Yes, you can. As Saga said, you have a annotation named JVM name, which I actually don't use because I like my symbol names between the JVM and Kotlin to be the same. I think using JVM name is usually causing confusion, and you should be very careful about using it. But if you remember the original code, it was like this: object hello and JVM static. That is how the original code that was converted looked like, if I remember correctly. Let me just quickly name this hello 2 and just making sure that I didn't do anything wrong. Yeah. So that's how you can name it. We're gonna go to what this object thing means in a moment. Okay, so now let's write some real stuff. I'm gonna write a Conway's game of life together with you. And I'm even gonna use behavior-driven development and test-driven development. Conway's game of life is a two-dimensional orthogonal grid of cells, an infinite two-dimensional orthogonal grid of cells. It's a so-called cellular automaton, and every new generation is done according to a simple set of rules. Every cell that is live that has 2 or 3 live neighbors survives until the next generation, otherwise the cells die. And every dead cell that has exactly 3 live neighbors will be born, becomes a live cell. Now, first scenario is an empty universe. If we have an empty universe, then the next generation must be, again, an empty universe. That's our first test. And I'm now gonna create a slightly different source structure. I want to have a Kotlin directory separately. You can put the Kotlin files in the Java directory, and for the build, it's going to work just fine. It's not necessarily going to work for all other tools. And for that situation, you can put your Kotlin code instead of in source test Java and source main Java in a directory tree, source test Kotlin and source main Kotlin. For Kotlin, it doesn't matter where the Java and the Kotlin classes are. And then we create a Kotlin class to run this piece of code. Actually, we already have it. I just have to move this. First of all, we want this to be in a package called Game of Life. and delete the template. And then we want this to be Kotlin code. And then, because it's Kotlin code, move this entire thing to the see if I clicked on the right thing right now. It partially moved wrong stuff. So just copy the directory and then just clean up the stuff. I can delete the Java directories. No longer need them. And here, we don't need these two. And here we don't need the acceptance test. And now I can run my acceptance tests. Yeah, in the template project, Cucumber was set up already. And the test fails, obviously, because I don't have the step definitions in place. When you look at this piece of code, what's different, what's the same with Java? The same is we have annotations, which I find great, because annotations, I find a very nice way of declarative programming. And what you see is if something is empty, you don't even need curly braces. It's also something I like. So this is my complete acceptance test class. And then let's write the step definitions. In Kotlin, you have the same visibilities as in Java, like private, package default, protected, and public, but they have different names. Private is the same. Package default is called internal in public. That's a bit like C#. Protected is the same, and public is the default visibility. You don't have to specify that something is public, it's public by default. And here you see something that as a Java developer, you probably will find very weird. I can put spaces into the names of functions. I can basically put all characters that are not having any reserved meaning for the JVM inside the name of a function. That means I can't use the dot inside the name of a function, and I think it's $ is also reserved. But I can put a lot of other things inside my function names, including spaces. And for tests, I find that a very attractive thing. You can see functions have a keyword in Kotlin. Yeah, that's you can say it's redundant, but at the same time, it's actually more consistent. If you have a keyword for classes, why don't you have a keyword for functions? You can see the sequence between name and type is reversed. Now we're kind of going back and forth in the sequence between name and type In Algol and B, you had the name first, then the type, also in Pascal. In C, it was reversed. You then had the type first, then the name, and then all the languages that followed it, like C++ and Java, kept the sequence, first the type, then the name. And now we are reversing it again. Yeah? If you look at the trends, also in Golang, you first have the name, then the type. The reason is just that our attitude towards types has changed over time. We appreciate the value of types that they give to robustness and to detecting certain types of errors early. That's why we still have those two groups of languages, JavaScript and TypeScript, for example, or Groovy and Clojure on one side, and Java, Kotlin, Scala on the other side. But we appreciate also that names of symbols are more important and more communicative to developers than types. That's why the names in the new languages usually come first. And then let's do the other step as well. And it was the next generation must be. I keep them empty for now. This test will obviously pass because there are no implementations. What you can see is annotations work the same way as in Java. And you can use Java libraries in Kotlin just like that, as long as you're on Kotlin JVM. And you don't need special Kotlin versions of your libraries. There is no Cucumber for Kotlin because you don't need a Cucumber for Kotlin. If you use Kotlin on the JVM, you use Cucumber Java. If you use Kotlin on JavaScript, you just use Cucumber JavaScript. You don't need a special Cucumber for Kotlin. Okay, that's the next piece of code that I want to have. I actually want to increment my universe. Hold on, no, that's what I want to do here. I want to increment my universe. It means I need a universe. I need a universe class in my production code. So let's create that. And one of the things that's really great about Kotlin is it goes way more than Java, ensuring the consistency of your initializations and values. There are two aspects about this. So one aspect is it here says, and Java wouldn't have said this. Java would have just said, okay, you declare it, but you don't initialize it, so it's going to be null. In Kotlin, for all types, there actually is a mirror type, and the normal types must not be null. If I want my argument here to potentially be null, I have to append a question mark. That means here, I could append a question mark and say equals null. Then I have this line being the same thing as in Java, saying universe, semicolon, because then it's initially initialized with null. And another way I can do it in Kotlin is to say, I know it's null for now, but I know it's not going to stay null forever. And once it's not null, it's never going to be null again. That's for what I can use late init. But I put it in the wrong place. It has to be late init var. And with that, I tell Kotlin, this is a variable that's not going to be null, but I'm not going to initialize it right now. It's going to be initialized a little bit later. And then here there's a plus plus. That's a cool thing. Kotlin has operator overloading. You can create overloaded operators in Kotlin, not just like Java, which has this one and only overloaded operator, the string concatenation. You can overload operators very nicely. Yeah, so here in this case, I'm gonna use that. Now I'm just gonna return a copy of the current universe. That I have to make it a data class. Data classes need a primary constructor parameter. Just to satisfy the compiler for now, I'm gonna give it something. It's gonna disappear. It's just for satisfying the syntax right now. When you have classes in Kotlin, you have more options of what types of classes you create. Yeah, you can obviously create normal classes like in Java, and you can create enums like in Java, and you can create interfaces like in Java. But you also have so-called data classes and sealed classes. Data classes are classes that automatically have equals and hash code and toString based on the fields of the primary constructor. And this, what you see here, is a constructor and a field declaration at the same time. If you get more of them, you typically then write your Kotlin code like this. And data classes automatically have a copy method, which allows to create a modified instance of the current object. So and then you can override fields individually. Like in this case, I'm just assigning 10 to foo, just as an example. We're going to do something slightly smarter in this copy method soon. And now I can just write universe plus plus because I'm using this overloaded inc operator. That's operator overloading. Okay, so
sorry, I have a question. So you mentioned universe is late in it, and in line 14 it's being incremented. So what's the initial value there?
This code, it's a good question. This code would actually throw a null pointer exception because my universe is late in it, but I don't initialize it anywhere.
All right. So it's not compiler, it's a runtime exception then.
Exactly. I would still get a runtime exception. This is the only way how you can trigger, there's two ways how you can trigger null pointer exceptions in Kotlin, despite using Kotlin syntax perfectly well. One is you do a late init and use it wrong, like I'm doing on the screen right now. I'm using the late init wrong. That's because the code is still not complete here. There should actually be a universe equals parse spec. Now this piece of code is just not written yet. And the other way is you cast, and you cast wrong. Now these are the ways how to still get null pointer exceptions in Kotlin. Good question, thanks, and well spotted. Yeah, it means you're paying attention. Cool. Is your question answered?
Yes, thank you.
Yeah. So I'm checking the questions right now. Harshad asks, is it mandatory to specify the type? yes, unless the type can be inferred. And there are a lot of situations where the type can be inferred. We're going to see such situations. When type inference works, you don't need to specify the type. The type will be specified implicitly by Kotlin for you. And Vishal asks, what is the naming convention, best practice? Same as in Java? Yes, same as in Java, except in tests, you really use the feature that you're never gonna call these methods yourself. They just have to be present, and they just have to be distinct in their names. And the primary purpose of these names is not to be good for the caller. The primary purpose of these names is to be good for the reader. And that is why, in this case, I don't follow Java conventions in my tests. I just make the test method name the most readable thing possible for the user, for the reader, for the fellow developer looking at the code. Can you give the name as a sentence? Yes, you can. That is a valid test case name. Yeah, I mean, it's a bit trivial in this example, but yeah, you can do that. You can write full sentences. The only thing you can't do is you can't put a full stop at the end. Yeah, because the period is not an allowed character. Use the period and it's gonna go red, but you can use commas if you like. Use exclamation marks. Yeah, that works. You can replace your full stops with exclamation marks if you're a grammar Nazi. Any other questions for now? No, I think that's it. I hope your questions are answered, and keep on asking. And in my chat is a little bit more on the right side of my screen. In case I'm ignoring the chat for too long, please just unmute yourself and drag my attention to the chat. Okay, so let me show you how to write a point class in Kotlin. A point class is something we're gonna need for the game of life anyway. So I'm gonna write a point test. And unit testing works the same way as in JUnit. Kotlin actually comes with its own unit test API if you want to write portable Kotlin code and you don't want to limit yourself to the JVM, then don't use JUnit directly, but instead use Kotlin's test API. Kotlin's test API is then mapped to JUnit. And, what do we want with points? We want to check if 2 points are equal. Equal points are equal. It's kind of a pointless test somehow, but it still serves as showing you something about Kotlin. So val p1 equals 0.00 and val p2 equals 0.00. Assert equals p1, p2. Expect these two to be equal. That fails because we don't have a point class. That's fine. So I create my point class. And then it still fails because I don't have my constructor. It doesn't take an X and Y. Now it takes an X and Y, and I can run this test. and it says they're not equal. They're not equal because normal classes in Kotlin behave the same way as in Java. That means equality is identity. But what I want here in this case, and Chintan said it on the chat here, is that I want that my fields are automatically included in equals, and that is where you make a data class. A data class is a class by which the identity is not represented via the object reference, but for which the identity is represented through the values of its fields. And then when we use a data class, my test passes. Now the test passes. So that's the difference between a normal class and a data class. A normal class is like every other Java class. The identity is first represented by the object being a different object, and if you want it to be something else, you have to program it. A data class is a class for which the identity is represented through the values of its primary constructor fields. Now this test passes. We can also check that the hash code is equal. And if you know Java, you understand that there is a certain contract about equals and hash code that code should satisfy. And your expectation, and of course it's a fulfilled expectation, is that Kotlin satisfies this. So the hash codes of these two are equal. We can make the counter test by creating two different points. Points are not equal. Actually, that's not a nice name. Equal points are must be equal. That's a better test case name. And in this case, different points must not be equal. And then we say 1, 2 and 2, 1, and make it a not equals. And the test, and it obviously passes. So, data classes. What do we need to do with points in a game of life? One of the things is we want the neighbor.
Excuse me. So, excuse me. This might be a silly question, but what is that hash code for?
That's a good question. Yeah, if you're not a Java programmer or not have not done a lot of Java code, then you don't know this. Every object in Java has a so-called hash code. The hash code is a 32-bit value, and this 32-bit value has the following requirements. The hash code of two equal objects must be the same, and the hash code of two unequal objects should be different. And the hash code is used to optimize the performance of data structures like hash sets, hash maps, and so on. They all use a portion of the hash code bit, or actually a specially hashed hash code, in order to index the arrays that contain the buckets of the hash map. That's what the hash code is used for. And if your objects do not implement the contract of hash code correctly, Your objects cannot be used in data structures like sets, and they cannot be used as keys in maps. Does it answer your question?
Yes, pretty much. Thank you.
So it seems data classes are overriding the equals in the hash code.
Yes, they are. And that's a good opportunity to use our Java disassembler again. Game of life point. And when we look at the disassembly of the point, what we can see is the code that was generated. We see we have getters implicitly. Yeah. Actually, I don't want them, and I'm going to show you how we're going to get rid of the getters. We have the constructor with the 2 parameters. We have a component 1 and a component 2. So not only do you get getters, you also get index component methods. And we also don't want them. You have the copy function that I mentioned before for data classes, and you have a copy default. They are using each other. So that's something here. And here is something which is very interesting. If you look in the copy function, line 6, invoke special init, what is that actually doing? That's calling the constructor of its own class. That's something that Java code only ever does in its constructors. But that's not a limitation of the JVM. It's only a limitation of the Java language. The JVM is much more capable than you see from Java. And in the JVM, a lot of things like invoke special and invoke dynamic have been added, not for the Java language, but in order to support other languages like Nice, Groovy, Scala, and now Kotlin better on the JVM. That is why Kotlin can be efficient on the JVM, although it does things that look totally weird for Java. Then this is the other part of the copy. Then we have a toString method, and you see the usual Java stuff with string builder. And we have the hash code, and you see that it uses the fields X and Y, and also the toString uses the fields X and Y. And we have the equals using the fields X and Y. So that's the decompiled class. So data class, this one word data gives you a lot of stuff.
One more question I had, Christian.
Yeah.
So you have defined those assert equal method. So where is it implemented exactly? Is that a static import?
Good question. Assert equals and assert not equals are static imports from the JUnit assertions API.
Okay.
And they are static imports. In Kotlin, you just do import. Kotlin doesn't care whether it's static or not. You just import the symbol.
Okay.
I have now made the X and Y private. And when I compile again, for that, let's just run the tests. And then I go to the disassembler again. We no longer have a get X. We no longer have a get Y. We no longer have a component 1 and a component 2. So just by making them private, I no longer have getters. Yeah? These are not actually fields. They look like fields. So, but these are properties, which means that your access is actually routed through getters and setters, but you don't have to write them and you don't have to call them. That's something that Kotlin does automatically for you. If you make a property private, it doesn't have getters. And if a property is public, like it was before, but it's val, so you can't change it. Val is like final in Java. Then you have getters, but you obviously don't have setters. That's something which, where I think they're making a huge mistake in the language design of Java. So we see the usefulness of data classes in Kotlin, and other languages have done similar things before Kotlin. Yeah? Kotlin wasn't the first language to do something like data classes. We see the usefulness of data classes because with so little code, you get so much done for your data structures. And Java is copying this. Java has introduced the concept of record classes. And in Java, you have no means of suppressing your getters, which means that despite that they can copy from Kotlin, they make it less powerful and less useful than it is in Kotlin. I think the language designer of Java that is currently in charge, Brian Goetz, is not competent. Yeah? He's living in an ivory tower of specification and does not care about how useful the language is in the real life, and that is killing Java. That is what drove me to Kotlin. Okay, let's continue and look at what else do we want in a point class. Yeah, we can already compare points. I can show you in the test. We can also say assert true p1 equals p2. And when you do assert, when you use the equals operator in Kotlin, it's not the same thing as in Java. The equals operator is actually, you see, it brings me here, but it's actually an overloaded operator for the equals method. So here I equivalently can say assert false of p1 equals p2 and run the tests, and it's going to work. For the situation where you really need identity instead of equality, you simply use the triple equals operator. Then this test is going to fail because these 2 points are not the same point, they're just equal points. That's expected to fail. So equals is overloaded to be the equals method. It's also a useful thing. Okay, next thing that I want is, I actually don't want to write point as a constructor call. I want to write P. That's of course not according to the naming conventions, but having a good DSL, a good domain-specific language, is something that, in my opinion, totally trumps naming conventions. And then I can just say P. Something we all know from maths or geometry, that you just specify points by saying P, and then you put the coordinates in the parentheses, and that works. And there is another way how I can do that. I have done this with creating a separate function, but instead of creating a separate function, this is basically a factory method, yeah, that I've created here. This is the same way how I can do it in Java, but I could also say type alias P equals point. And then wherever I write point, I could also just write P instead. Now that's Then the same thing, just that here, this is now the direct constructor call. That's type aliases. Yeah, I can give types other names in case I'm using them in a specific context, and in that specific context, the other name makes more sense. Now let's implement the toString method, because for toString, we want this to be very much in line with our DSL. We want that I call toString of P one, two, that I actually get exactly this string. And that test is going to fail because the default implementation of toString is not working like that. When we look at the difference, you can see expected is this and actual is that. So I'm just going to implement my own toString method here. And what you can see here is another Kotlin feature, which is string interpolation. That's a feature I so badly miss in Java. It's such a useful thing from the perspective of testing to make sure that your objects, your data has meaningful string representations. And if you want to do this in Java, it's just a pain in the ass. That pain got reduced in Java 5 with the introduction of format, but it's not the same as string interpolation. This is just so easy, neatly, nice to read, and that is making my test pass. What you also see here is that in Kotlin is quite strict about your awareness of overriding things. In Java, it's just a beauty thing, whether you use the override annotation. In Kotlin, it's a compile time mistake if you forget to declare that a method is meant to override something in your class hierarchy. I just saw there was a request to show you the Java P command. I'm going to paste it to the chat for you. Copy. And there we go. Now you have it in the chat. Vishal asks, what is the difference between a property and a field? A field is the physical storage of data in a class or a structure. A property is the logical representation of an attribute consisting of the field that implements the property, if necessary, and the accessors like getters and setters as the property. And in some languages, properties and fields are really the same thing, like in JavaScript. And in some languages, fields and properties are different things because they have some level of infrastructure around fields that make them properties. These are languages like Java, Kotlin, and C#. Java doesn't have syntax for properties. Java only has a convention for properties, which was created with the Java Beans specification in the early days of Java. The convention is that if your field name is X, your property accessor for reading the property is getX. Unless it's Boolean, then it should be isX. And the accessor for modifying the field is setX. And with reflection, these things are found. And in Java, it means if you write .x, it's actually the field, and you have to explicitly say get x and set x if you want to use the accessors. In Kotlin, the .field access syntax is actually property access. We're going to see that in an example. I hope that answers most of the question of the property difference. And if we don't override toString where it gets it from, something like object in Java, no data class actually provides an implementation. If we scroll back here, we can see that one of the methods that was created here, this toString method, is the auto-generated toString method. Yeah, I have not done a new call to Java P. This is coming from the data class, and you automatically get the class name, the field name, then the value, then comma, the next field name and equals, and the value, and then the closing brace. Yeah, so it's an auto-generated toString. It's not an inherited toString, which I also like, because the toString method of object in Java is pretty useless. The hash code, what do you do with the hash code? Knowing the hash code of the object, in 99.99% of the cases, it's useless to know. What you want to know is the values of the fields. And the default toString method of data classes in Kotlin gives you the values of the fields. I just didn't like the syntax in this case. Normally I do. I just don't like it in this case, because in this case I want the code representation and the data representation of my data to follow a DSL, which is P and X and Y in the parentheses. That's why I've overridden the toString method. I hope that answers your question about the override and about the toString. Back to the test. That should be passing now. And that's how you override toString. Okay, what I already know, because I know the problem statement, one of the things you want to do with points is you want to add 2 points together. I want to add points. And the plus is red because I haven't implemented the plus method yet. Just go there and say create member function point.plus, and we return a point. I can say return x plus p dot x comma y plus p dot y, and that is my plus function. And run the test. And it passes. That's operator overloading. Yeah, we had this a little bit already. I find it very useful. And for example, I recommend Kotlin to banks because Java is extremely popular at banks for good reasons. But what is the data type that a bank needs to use in order to deal with financial data? It's not int, it's not long, it's also usually not big integer, it's big decimal. And in Java, if you use big decimal, your code just explodes in size on the screen. Unless you use Kotlin, because then you can just overload your operators and everything becomes easy. Now that's operator overloading. And actually, we don't need P1 and P2 separately. We can just directly write this that way. Works perfectly well. One of the things that you may notice with my code, and it's not because we are in a training session, my real production code looks the same way, is my methods are always very, very short. I try to avoid long methods like hell. And my favorite length of a method is just one line. That's my favorite method length. And now let's look at something you can do in Kotlin if you have such short one-line methods, like I have here. When we look at clean code, having short methods with meaningful names is one of the instruments we use in clean code in order to structure code and make its intent transparent to the reader. There's a very famous quote from the book Structure and Interpretation of Computer Programs, which is written by Sussman and Abelson, which is, programs should be written for humans to read first and only incidentally also for machines to execute. Very interesting statement, but it's a profound truth about the problems that we have with code, or the problems that we don't have with code. Yeah? If code is well written, we obviously have less problems with it. And when you write clean code, writing short, tiny functions with good names is one of the things you do. Then if you do this to the extreme, in a good way, you end up with functions as short as these. In Java, that's where you end. That's where you stop. Not in Kotlin. Kotlin has a special reward for clean coders. I'm going to show you now. Kotlin has so-called expression functions. An expression function uses the assignment syntax, and what you have on the right side of the assignment is your return expression. And because the type can be inferred, because that is a string, I can even remove the explicit type specification. That's the point, so I can remove that as well. And now that's Kotlin code. And that
Excuse me, so
yeah.
if I don't want to return anything from the function, can I still use this?
Yes. In Kotlin, you have a special type of void. It's called unit. And if the type cannot be inferred, it's automatically going to be unit. And yes, you can do this even if your function does not return anything. And the demonstration for that is test cases. Perfect question, the perfect moment. Thanks for asking.
Thank you.
You can run the tests, and they will run just fine. And now not only is our production code really Kotlin, now this test code is also really Kotlin. So that's operator overloading, a beautiful thing. Just when you do it in your own code, don't do it the way C++ did it. I think C++ spoiled the topic operator overloading for the industry for like 2 or 3 decades until we recovered from how operator overloading was overdone in C++. Do it moderately, do it in ways that delight the reader. Don't do it in ways that confuse the reader. I think that operator overloading in C++ was often done in esoteric ways that confuse the reader. I like to write code in a way that someone who doesn't know much about the programming language can still easily understand the code. Yeah? And I mean, of course, there's always a room for argument, but I think that this piece of code, add these 2 points together and say that it has to be equal to that, is pretty easy to read and understand, even if you don't know Kotlin. Okay. Can you name the operator overloading function to addition? No, you can't. There is a mapping between operators and overloaded function names. Now, the selection of the operator is coming from the function name. There's a table that says the plus operator is the plus function. The plus plus operator is the inc function. The minus minus operator is the dec function, and so on. There's a table of this name mapping. This name mapping was chosen in a way that a lot of the functions that are present in the Java API, thankfully, the Java API is one of the most consistent APIs regarding naming. It's also not perfect. It's like everything created by humans. Yeah, we are not perfect. And it's good. Our imperfection is from which we draw our creativity. The names of the overloaded operators have been chosen in a way that a lot of the API in Java functions as overloaded operators. Okay, I hope that answers your question, Chintan. Any other questions that I didn't see? Okay, I hope you're good with the questions. Okay, then I'm gonna stop the live coding at this point, and I'm gonna go to an existing implementation of Game of Life in Kotlin to show you more stuff. More of the beauty of Kotlin. That's the complete implementation of the Kotlin point class. I've named it point2D here, and I've made a point interface, and ignore that for now. I'm gonna talk about it in a moment. You see the plus function. You see the type alias. Type alias is private, which means it's only valid in this file. You see a range too, and there's also an operator. There's a range operator, which is ... And that's how I get my neighbors. So what is this neighbors thing for a point? If you have the point 0, 0, your neighbors are -1, -1, -1, 0, -1, 1, 0, -1, 0, 1, 1, -1, 1, 0, 1, 1. The 8 points around the current point, the current relative origin, are the neighbors. And in order to get my neighbors of a specific point, I just have neighbors around the origin. So that's the neighbors around the origin. And the origin itself is not included, so it's filtered out. That's a lambda. That's how you do lambdas in Kotlin. I'm going to show the syntax in more detail. Also, what nice things are done in the API with that. And then I say a range is I'm iterating from x to p dot x, which could in this case be -1 to 1, and map this to say, okay, for my x, I create another iteration from y to p dot y. So in this case, again, from -1 to 1, for example, and map this to creating that corresponding point. And then because I have a list of lists, I flatten this into one flat list. And that's how I implemented the range operator in Kotlin to get my neighbors. That's a very nice, neat piece of code. And if you would want to do something like this in Java, you can actually do this, but you have like 20 lines on your screen in order to do the same thing. So in Java, I actually don't do this very often. And then my actual points neighbors are the neighbors around the origin mapped to simply add the neighbor point to the current point. That's basically doing the offset to the current point. That's my point2d class in Kotlin. That's my universe class in Kotlin. And that's another pinnacle of clean code and using Kotlin to drive clean code to its extreme, something you can't do in Java. Spot the empty lines, because all my functions have meaningful names, and because all my functions are so short that I could use expression functions, I no longer use empty lines between all the functions. Instead, I can use empty lines to group different sets of functions together. It becomes an entire new way of structuring code. And if you look at the same class in Java, it's about almost 3 times the size. So that's how beautiful Kotlin code can look like. Let's look at a few things that you see here. There's one thing you see here that we've already used elsewhere. I've used a type alias in line 3. I've said for my universe, I'm actually not calling the stuff point, I'm calling the stuff cell. That's a really lovely thing that I like about Kotlin. It makes choosing the vocabulary easier. Because in Java, I can either name it point, which means my vocabulary is reusable, but my vocabulary does not match my problem statement, or I can name it cell. Then my vocabulary matches the problem statement, but cell is not really reusable. So what I can do in Kotlin is I say my type in its definition is getting the reusable name, which is point, but where I'm using my type in a specific context, if that specific context has a more business or problem domain specific name for that type, I can simply use a type alias. And a cell is a point. But when I'm talking of the context of the universe, of game of life, I'm calling it cell. So that's what I do with a type alias. There was a question from Chintan that I quickly want to answer. The question was, can you also do plus? Yeah, you can. Just go here and replace overloaded operator with function call. That's the same thing. And of course, it works back. Yeah? Replace with plus. So yes, you can call the overloaded operator function directly as a function call. And if you call Kotlin from Java, then that's obviously the way you have to do it, because you can't use the overloaded operators in Java. But yes, and you can flip with the Alt-Enter of IntelliJ IDEA back and forth between the operator and the function call. I hope, Chintan, that answers your question. Now let's look at this piece of code here in line 16 to 22. Because that is something that you cannot do in Java. It's a little bit like monkey patching in Ruby, if you've done Ruby code before. What I'm doing here is I'm creating so-called extension functions. But let me kind of first of all reverse the extension functions. Let me write this piece of code as if it were Java code. Now this piece of code is written in the way how you would write it if you were a Java programmer that just learned Kotlin and has not encountered this feature yet. So you have a group of functions that all take cell as an argument. Yeah? How do you know the cell in the universe is alive? The cell in the universe is alive if the cell is in the set life. Yeah, the in is another overloaded operator. The in is an overloaded operator that goes to the contains function. And that means not in is also contains. It's just negated. So that's is alive, is dead. Yeah. So what Kotlin offers you to do is, it says if in a specific context you wish your class would have another function, but it doesn't make sense to add this function to the other class. Yeah, the point class can't check if the cell is alive because the point doesn't know about the universe. But when you look at the universe class, you wish is alive would be an instance method of cell or point. Yeah? Then what Kotlin allows you to do is so-called extension functions. They're also sometimes called receiver functions. So you can do the same thing as you do with OO syntax without modifying the original class. You move something from being the first parameter to basically, if you want to call it like this, the 0th parameter. You move it to before. So for is alive, we can say cell but is alive. And then the cell is no longer a parameter, it's the 0th one. And how do we call the 0th parameter in Java or Kotlin? It is this. Which means in the call that is no longer is alive cell, but cell dot is alive. And it means that in the context of this function, you now actually have two this references. You have the this reference for cell, and you have the this reference of universe. Should I have to refer to the universe, like I want to say this.life, this is now the cell, I can qualify it by saying this universe. And qualifying this as cell is redundant. The inner one is not allowed to be qualified, but the outer ones, in case you have to access them, you can qualify them with the @. If you don't qualify, it would automatically perform search inside out. The cell doesn't have life, so life refers to the next instance, which is universe. And that is what we can do with the entire set of code here. And that makes the code much more readable from a perspective of what it actually shall express. And it makes the lines shorter. See how most of the lines become shorter. Revert, everything, that's extension functions. It's really a lovely feature of Kotlin, and allows code to be much more expressive, and you can use it for all kinds of interesting stuff. Yeah, whenever you feel like a class should have a method and the class doesn't have the method, you can just declare the corresponding extension functions. For example, let's say you would like to have a special function in class string. You can always say fun string dot join with comma. Then do whatever you like. And then you could call join with comma on the string class. Or you could say join to, that maybe makes more sense. And then say you have list of strings, and say strings to join is comma strings. String to join. So you can write code like this, just extending existing classes with new functionality, put that in a context. And if you look at something like Spring, what Pivotal has done, they have written code like that, especially for Kotlin, to make Spring with Kotlin an even more enjoyable experience, like the thing in Java. Okay, there's a question about point star. The star here is like the question mark in generics in Java, and point here is an interface, because I wanted to make my code extensible to have universes of multiple dimensions possible. So I've made point an interface, and I have a 2D and a 3D implementation. And the star here is a generics wildcard. Yeah. I hope that answers your question, Vishal. Here again, you see the string interpolation, operator overloading. Let's have a look at lambdas. This is something that looks half familiar to you if you're a Java programmer. If you're a Java programmer, you know the arrow syntax. I know that's not an answer for your question, Saikat, but you construct a universe in that situation was actually redundant, so I've removed it. The arrow syntax in Java is for the actual lambda, where you have the value and the code. In Java, at this place, you would actually need to declare an interface or reuse one of the existing interfaces. In Kotlin, you don't need to declare new interfaces if you want to have higher order functions. You can just declare the type signature of your higher order functions in place. So predicate is a parameter that is a higher order function mapping a point to a Boolean. And then you pass it on to the filter function in this case. Let's look at filter. That's coming from the API. Here again, you see that predicate is a higher order function mapping your T. You can see that the type specifiers for generics, they work very similar to Java, especially regarding the positional syntax. And that, and then you can see this is in filter 2. And in filter 2, the predicate is then used again. When we go back to the neighbors here, you can see my argument is a lambda expression. How does the caller syntax look like? It looks like this. I can actually change it and say move lambda argument into parentheses. Yeah? You can write it like this. Yeah, then it looks like a normal function call, and you have the lambda inside the function call. But the Kotlin way of doing that is that you move the lambda out of parentheses. So it was even done yellow. It's not Kotlin style. You move the lambda out of the parentheses. If you have only one lambda argument, and the lambda argument is, if it's only one and you don't give it a name, then the name will automatically be it. You also write it like this. And you have it totally like Java. If I rename it to just it, then the it arrow becomes redundant, because it is the default name if you have just one lambda argument. Now let's go to the test code. There is something I want to show you about lambdas here in the test. 2 is an operator for maps, and 2, not really an operator, it's actually an infix function that creates a pair, and mapof takes a var list of pairs. That's how you create maps in Kotlin. So this map has 3 entries. New line is mapped to this lambda, star is mapped to that lambda, and dot is mapped to the empty lambda. And a key difference between lambdas in Kotlin and Java is that in Java, lambdas are not closures. In Java, lambdas are just a more memory efficient and more source code efficient way of writing anonymous classes. In Kotlin, lambdas are true closures. Now, what is the difference of that? Because that sounds totally like just an academic explanation. The difference is that a closure can access and even modify the variables of the outer function in which it is included. In Java, it would be impossible to write a lambda that does line plus plus when line is a local variable. you could not do that in Java. In Kotlin, you can. So that is something where Kotlin, of course, does some magic in the background. Kotlin promotes line from the stack to the heap. But it's really useful that you can write the code like this. Now, the Java version of this code is an entire class spanning about 50 lines. So closures in, so Lambda expressions in Kotlin are closures, and therefore you're allowed to modify variables of the outer code. That's something I, of course, don't often do, because that breaks functional programming. This piece of code uses functional programming features, but this is not functional programming that I'm doing here, because I'm modifying values of variables. But I'm not dogmatic about paradigms. I'm pragmatic about paradigms. I use them when they make my code easier to understand and easier to maintain. In 99% of the cases, that happens. Sometimes using a paradigm would make my code more difficult to understand, and then I don't use it. Now to the constructor. Now there's still an open question about the constructor keyword that I have just sneakily removed from the universe class. I can overload constructors, and in that case, I need the constructor keyword. Constructor keyword is what you use for overloaded constructors, and this piece of code here is also a constructor, but the word constructor in this location is redundant, because when you open parentheses after the type name, it is the constructor, the primary constructor, and the constructor keyword is used to declare secondary constructors. I could then say we have rules equals Conway, rules and life equals empty set. And but I hardly use overloaded constructors. Yeah. For what do we use overloaded constructors in Java most of the times? Most of the times we use overloaded constructors in Java because we actually want to make parameters optional and give them default values. Here is something that Kotlin has, we can say, copied from Python. Yeah, it's not like Python would be the first language to do that, but the popularity of Python and the popularity of that feature in Python have definitely taught the industry the usefulness of that feature, which is to allow named parameters and to allow default values. So when we look at this constructor here, and that also works with functions, by the way, it not only works with constructors, you can see that my parameter rules is assigned to Conway rules. If I write a piece of code where I say val universe equals universe, I can just directly initialize my life, for example, as an empty set. And that means my rules have been initialized as Conway rules. If I want other rules, like high life rules, then I have to specify the rules. Kotlin allows you to use named parameters, and so there's an interesting debate going on about design patterns, and also a very misleading debate when it comes to programming paradigms. There are people that claim that design patterns are an OO thing, and in functional programming, you don't need design patterns because you have higher order functions. That's rubbish. It's rubbish because it's comparing apples with peaches. It would be like saying in object-oriented programming, you don't need all the FP concepts because you have polymorphism. Yeah? Higher order functions does not mirror design patterns. Higher order functions mirror polymorphism. Actually, the overlap between higher order functions and polymorphism is like 60 or 70%. Higher order functions and polymorphisms are mostly just two different names for the same thing, looking at it from two different angles. From the angle of functional programming, you call it higher order function. From the angle of object-oriented programming, you call it polymorphism. Now, what are design patterns? Design patterns are concepts, reusable concepts, to solve reoccurring problems in the code so that we don't have to reinvent the wheel. Some design patterns address deficiencies of programming languages. These are design patterns that we may get rid of. One famous example in Java is the builder pattern. In Java, I regularly use builders to make the construction of objects easier. The builder pattern is a workaround for Java only supporting positional parameters. If you have a language like Python or Kotlin, you will never use the builder pattern, or almost never, because the main problem that the builder pattern solves, that you only have positional parameters, does not exist. In Kotlin and Python, you have also named parameters and default values, and therefore you don't need builders. So some design patterns are workarounds for language deficiencies, and Kotlin has tried to address this by improving the language and making it more powerful. Other design patterns like strategy, composite, and so on, they have nothing to do with language. They're just solution patterns, and you use them in functional programming just the same way as you do that in object-oriented programming. Okay. In this piece of code, most of the things are really very straightforward. So there's something I want to show you about Kotlin, which I find very useful. This is this with default, which is a specific instance of something more generic that I want to show you. This is something specific to maps in this case, but there's a question that shows I haven't explained it well enough. It's not like you can't use the builder pattern, it's that you don't need the builder pattern. Let me just create some piece of code where we immediately would like the builder as if we have Java. Yeah, so let's create a piece of Java code. And we say private string salutation, private string first name, private string middle name, private string last name, private string address 1, private string address 2, private string address 3, private string pin code, private string city, private string country. Then how does the constructor for this look like in Java? And then I already am at the problem, what is next? Yeah, pin code, city, country, and let's insert state in between. Pin code, string, city, string, state, string, country. And then, yeah, salutation. And thankfully, we have code generators, but these code generators are actually not a good thing. These code generators make it easy to create boilerplate. We should not create boilerplate code. We should design our APIs and our languages in ways that we don't need boilerplate. Okay, so how does the constructor call in our test look like? Do we really want to write code like customer C equals Mr. Santosh Kumar at 5411021 Pune, Maharashtra, India? Do we really want to write stuff like this? And if you've paid attention, you've already spotted how error-prone this is. We have a long list of positional parameters. I forgot the middle name. What about the middle name? I forgot some address lines here, yeah? I forgot address lines. This is expected 11 arguments, but found 10. So here we need another null. Positional parameters, if they grow in number, are a maintenance nightmare. And that is why in Java we use builders. You then say class customer builder. And actually, I think we have a builder generator even here, don't we? Let's see. Code generate builder. No. Okay. So class customer builder. And then there are different ways how you can implement the builder pattern. We have a mutable POJO that makes it easy. So we can just say we have private customer build equals new customer. Then we give this another constructor. That's for the builder. Then we have all these methods. Public customer builder with salutation. And then we say string salutation. And we say build.salutation equals salutation. We have to make them accessible for the builder. So either we would need setters, or we make them package, or we put the customer builder inside the customer class. Yeah, there's different ways how you can do this. And return customer builder. And then we repeat this ceremony for, well, not customer builder, this. And then we repeat the ceremony for each and every field that we have. I'm not going to complete this because this is just a pain. And why this ceremony? Only so that instead of writing this piece of code, we can write the following piece of code. Just so we can write this. And why do we want to write this instead of that? We want to do that because we don't have named parameters. The with calls of your builders are workaround for the absence of named constructor parameters. Yeah, and there was a question, can you use Lombok? Of course you can use Lombok. And by all means, if you're using Java, please use Lombok. Yeah, some people think Lombok is a hack. I agree, but it's a hack very much in dire need in order to reduce the boilerplate of your Java code. So this is all boilerplate. Let's convert this to Kotlin. Now, we're going to move all that into our primary constructor. Remove builder because we don't need it. Because now in Kotlin, I can say this. And now look how short this code is compared to the Java code that we had before. That's why I said that builders are only a workaround for a language deficiency. They are a workaround for only having parameters that are positional and not named. In Kotlin, you have named parameters with default values. Therefore, you don't need builders most of the time. I hope this explanation made it much clearer now than it was before. Okay, I got the feedback from Anupan that explained it, yeah. And Vishal, yeah, definitely you can use Lombok. Please, if you do Java, use Lombok. Okay, so that's the question about the builders. And that's a demonstration of the default parameters and the named parameters. I'm not going to dive into yet another project. to show you a few pieces of code with a few features of this. So we are gonna look at delegates. So this project is something we've done for a client where we take project information from Jira and we calculate, based on the dependencies of the project, a project plan. And that's a algorithm known as Gantt algorithm. Gantt charts and project planning are based on that. And if you're a software developer, you might say, oh my God, we don't do Gantt charts anymore. That may be true in a lot of software development, but there's a lot of non-software projects also going on in the world. And it makes totally sense for some of the projects to use Gantt charts. So we've supported that project by doing some calculations around that. And there are a few interesting features that I want to show you that I haven't shown in the other code because they weren't used there. First feature I want to show you is companion objects. Companion objects are what you do instead of static fields with constants in Kotlin if you want these fields to be inside another class. Then you use a companion object. An object in general is something you can declare in Kotlin, which is like a singleton. Then date calculator, that's an interface. And you can see here that I can create an interface that declares that an implementation will overload operators. And you can do that. And in this case, I'm declaring that an implementation of this interface is going to overload operators on another class. A date calculator is going to overload the plus and minus operators of local date, adding a double, plus and minus operators of local date time, adding a double, and a minus operator on local date, subtracting another date and returning a double. Then an implementation is implementing this. And that's how that's implemented. Then what is this with holidays? I'm asking a date whether it's a holiday. How does the local date know that it's a holiday? Well, the local date actually doesn't know. For this, I have another interface called holidays that declares is holiday as an extension function to local date. And then I have something like a weekend holidays implementation, which says something is a holiday if the day of the week of that local date is Saturday or Sunday. And I have another implementation which checks whether this is a holiday in the German state of Berlin, where this knows everything about holidays in Berlin, including when Easter is. So that's how the date calculator, it has an injection of holidays. And with the holidays, it then asks the date, are you a holiday? Now that's the with. I wanted to show you and how powerful and expressive and modular code can become if you make use of these Kotlin features. The experience of writing Game of Life in Kotlin and comparing it with Java was one level of an eye-opener for me, because the Kotlin implementation is about half the size of the Java implementation. And then this experience has led us to say, let's give Kotlin a bigger try. Let's use it in a production project. And the experience of using it in a production project was yet another eye-opener, because we could see that the benefits in the production project are even bigger than you can see in a playground project. The code quality and the modularity have really gone up significantly. Then let me see, where is this other piece of code that I wanted to show? Yeah, I think it's that. That's a very beautiful piece of decoupled code. So we have a Gantt calculator that can calculate the dependencies, or based on the dependencies in a project, the start and end dates and durations of things. Yeah, you need to know two things. You need the duration and you need the start date, either by having a start date or by having dependencies and they have their end dates. And then you can calculate the end date, and that's how you calculate the entire project. But the key thing here is the customer didn't want to have one project plan. The customer wanted to have 4 project plans. The customer wanted to have a normal project plan, a pessimistic project plan, an optimistic project plan, and a project plan after the Gantt formula, which takes the pessimistic plus the optimistic plus 4 times the normal one and then divides it by 6. So he wanted 4 different calculations, but we only implemented one calculation, and we mapped this with implementations of activity. So we have an abstract class Jira activity, which maps it to a Jira issue. Then we have expected activity, which is the Gantt formula. And we have an optimistic activity, which uses the optimistic start from the ticket. So we just map this to different fields. What you can see here as well is properties with different getters and setters. So when we go to Jira activity, here we say, or actually up to activity, you see that in this interface, I'm actually not declaring functions. In this interface, I'm declaring properties. That's something you can't do in Java. Because in Java, you have fields, you're looking at the physical implementation, and fields are not polymorphic. They can't be, because they are data. In Kotlin, you declare properties, and properties are polymorphic because they are behavior. They are actually functions. They are getters and setters, or if they are val, they're only getters. And that's why you can use them in interfaces. If I would do this in Java, I would actually have 6 getters and 3 setters in this interface. And then when I look at an implementation like optimistic activity, there I'm overriding the properties. And when I override them, I can do things like saying, what does the getter actually do? And what does the setter actually do? In optimistic activity, the calculated end date is mapped to the optimistic end, to my issue from Jira. Now this is an extends that is calling the superconstructor. then what are these question marks? Yeah, there already was a bit of chat going on about the question marks. The question marks are Kotlin's way of dealing with nullability. If I do it like this, this means that duration is a double that is never null. If I add the question mark, it is like the duration is a double and it may also be null. Then when I access fields which are null, there's something I'm doing here. I say, if you want to read my duration, then I'm gonna check if I have children. If I have children, I'm gonna tell you my duration as null. If I don't have children, I'm gonna tell you my duration as looking at the issue's optimistic duration. If that's not null, I'm gonna give you the optimistic duration of my issue. If my optimistic duration is not set, if it's null, I'm gonna look at my normal duration. If my normal duration is not null, I'm gonna give you my normal duration. And if this is null, I'm gonna look at my pessimistic duration and give you that. That's what the Elvis operator, that's how we call it, the question mark colon is doing. The question mark colon is giving you the left operand if the left operand is not null. Otherwise, it's going to give you the right operand. So the dealing of Kotlin with null is far superior to Java. And a general experience of Kotlin teams is that they significantly reduce the number of null pointer exceptions that they get. I mean, null is an interesting story. Let me show you something around null. When we look at the origins of null, we end up at this person, Tony Hujer. He's a genius. He's a computer science pioneer. A lot of things that we do go back to his works. Yeah, see when he was born, 1934. He invented quicksort, the, for a long time, fastest sorting algorithm. Now we have a faster one, which is timsort. But timsort is simply based on quicksort and combines it with insertion sort, taking into account that quicksort is only the fastest for large amounts of data. And he's known for structured programming, and he's also known for the null reference. So what's the story about null? Speaking at a software conference in 2009, Tony Hujer apologized for inventing the null reference. And he said, I call it my billion-dollar mistake. It was the invention of the null reference in 1965. At that time, I was designing the first comprehensive type system for references in an object-oriented language, AlgolW. See how old OO is. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. That's what he says about his invention of null. Yeah? Was easy to do, but I think many of us share the experience that null pointer exceptions are painful. Kotlin is based on earlier works of JetBrains. If you are deeply into the IntelliJ IDEA IDE, you know that JetBrains offer an annotations library with nullable and not null annotations for your types, and that help Kotlin to inject code that will perform null checks. What is the biggest problem with null pointer exceptions? The biggest problem is that the cause and effect of null pointer exceptions are temporarily decoupled. The moment in time when the problem is caused is that you make something null. But the problem when the moment in time when the problem actually occurs is not when you make something null, it is when you actually use it and expect it to not be null. That can be hours later in the code. And it means you see that something was wrongly null. That's what you see in the stack trace of a null pointer exception. But what you don't see in the stack trace is when did it actually become null when it shouldn't. That's what you don't see in the stack trace. And that is what makes null pointer exceptions so painful. Now let's see how Kotlin deals with that. Let's go back to our game of life code. And let's say, just for the sake of demo, let's do a func dec equals copy, and say life equals null. And you see the compiler rejects this. The compiler says, yeah, null cannot be a value of a non-null type set. If I want my knife to be nullable, I have to add a question mark. And now when I add this question mark, you see a lot of other things go red. Here it says, only safe or non-null asserted calls are allowed on a nullable receiver of type set. Yeah, so Kotlin makes sure that as much as the language can of null safety checks are moved from the runtime to the compile time. And then when you bypass these checks, Kotlin still is very helpful, because whenever you assign to a non-null receiver, Kotlin will automatically compile an intrinsic that performs the null check at the point of assignment and not at the point of reference. So Kotlin is really great in reducing null pointer exceptions. That alone gives Kotlin tremendous value. In Kotlin code, I've experienced far fewer null pointer exceptions than in Java. Okay. The operator symbols sometimes become very cryptic as compared to English named functions. That's what Chintan said. That's true. That's why I recommend that you be careful about operator overloading. And that's something that I can immediately demonstrate in this piece of code here. Let's go to point test. And I think the equals overloaded is easy to understand. I think the plus overloaded for point is easy to understand. But the plus overloaded for universe, that's borderline. Yeah, that's more like a showcase. I'm not sure if I would really want this in production code here. Now that's to be taken with care. Then what are good reading resources for advanced features of Kotlin, like companion objects, extension functions, nullability, and so on? Excellent question. That's the wrong one. This one. When you just Google for Kotlin, you end up on the Kotlin website, and in the documentation you have an excellent description of the Kotlin language with everything you need, basics and advanced concepts, everything you need. Yeah. Also, Java interop, JavaScript native tools, everything you want or need is there. Yeah, classes and inheritance. Yeah, and then it shows you everything about classes. Yeah, initializer blocks. Yeah. We only have 3 hours for today's session, so obviously I can't go into each and every detail of Kotlin. There's just a few more things I want to show. But yeah, the Kotlin documentation is your go-to place for learning more about this. Yeah, so that's that. Then let's go back to this piece of code and so you apply and also. I think Jira and Marshall test is a good place to go. So apply and also something I wanted to show you. Oh, it's not entirely nicely formatted. And actually join these two applies together. Let's if refactoring is safe and I spot an opportunity for refactoring, I do it right away. I don't wait for later because later never comes. I do it right away. So what is this apply thing and where does it come from? Let's look at its implementation. This is the implementation of apply. What do we see here in the implementation? We see it's a public inline function. What are inline functions? Inline functions are functions which are actually not called, but where the compiler inserts the function's code directly at the call site. The public inline function, it takes a type parameter. It can apply to this type. Yeah? It's an extension function, so you can apply it to everything. Apply is there a global function. You can say it a global instance function without changing class object. And as an argument, it takes a argument block, which says you can call any code on that type, which doesn't return anything, and it returns the same type. Let's skip the contract thing. The contract thing is irrelevant for us. It then just calls the block and returns this. And we also have an also, but also calls the block on this, and the receiver is slightly different. This is apply and also. And to show you the usefulness of this, I'll first write this in Kotlin, but Java style. I haven't mentioned this, but I think it was pretty obvious by just looking at the code. In Kotlin, when you call a constructor, you don't type the new keyword. So now these two functions, create test book and create test book 2, are equivalent. They do the same thing. But I prefer Create Testbook over Create Testbook 2 because I prefer expression functions over functions that consist of a sequence of statements. I prefer expressions over statements. Yeah, that's something, when you do more and more functional programming, you really come to value expressions over statements because expressions have a higher degree of composability. Yeah? Statements can be only composed in sequences. There is no other composability of statements, where expressions can be composed by sequence, but they can also be composed by nesting. And that is a higher degree of composability. So that's why functional programmers prefer expressions over statements. It's just nicer composition. And when I look at this piece of code, and this piece of code looks like it is not convertible into an expression, because I need to store my issue in a variable so that I can actually modify my issue, because ID and rank are intentionally not part of the constructor. They're not part of the constructor because they are not part of the identity of the object. We use equals for issues, and ID and rank must not be included in the equals. So they can't be in the primary constructor. I could have created an overloaded constructor, but that would have complicated the issue class. So this is how a Java developer would write this piece of code. Now in Kotlin, I have apply, where I can say, I'm just giving you what I've just done. I'm giving you the same value. If I just do apply with an empty block, that's idempotent, which is Latin Greek for you getting the same thing. And then I can move this piece there. And because of the way how apply is defined to take a receiver block. This is actually this. This is the issue that I'm currently looking at with apply, which means I can remove this. And then I can inline my variable. And then I can convert my expression body and remove the explicit type specification. And that's how I end up with this beautiful, short, Kotlin style piece of code. And so apply and also are things in Kotlin that there's also a nice thing here that I want to highlight. It feels as if you can extend the language because of the expressiveness that these extension functions and receiver lambdas give you. But it's actually really just some Kotlin code that enables you to do that. There's nothing in the compiler to support that. It's just the basic syntax applied in a smart way and made available globally to all Kotlin, which makes us writing code like this. And that, again, increases your mileage towards converting pure OO code into object functional code, moving it closer to functional programming and combining the benefits of object-oriented programming and functional programming to create beautiful, maintainable code. Let's apply and also. Is it possible to look into coroutines? I'm afraid we are out of time, and because I knew we were not gonna achieve everything, I think we also hadn't planned this. But before I violate the agenda, let me just have a brief look at the meetup page, make sure that at least those things which I promised are delivered.
Christian, we started a bit late because of the.
We looked into Gradle migration. We didn't look into seed classes. Seed classes are classes that are halfway between normal classes and enums. They are a more sophisticated way of enums. It's a class where you are allowed to create subclasses, but nobody else is allowed to create subclasses. The keyword is just sealed. Yeah.
Christian?
How deals with null, yes, expression functions and receiver functions, and functional programming, lambdas, operator overloading, named arguments. We didn't do unpack and spread, and we didn't do destructuring, and not nested functions. Yeah, the problem is we just have limited time in such a meetup.
Christian, are you able to hear me?
Here, sealed classes. Now you just say sealed, and then all the subclasses have to be declared in the same class as the sealed class itself. It's a little bit like an enum, just that in enum you can't call constructors. In sealed classes you can call constructors. The sealed classes. And destructuring. Somewhere here. Let's just use the search. What? Why did the search go to the start page? Okay. Yep. That's the wrong part here. Destructuring. Here we go. So entry, map.entry is a field, is an interface with two properties, and because it has two properties, instead of saying entry, you can also say key, comma, value, and it will automatically take the two properties, so component 1 and component 2 of map entry, and assign them to the two names here. Whether the names are key and value or A and B doesn't matter. The first one is calling component 1 and the second one is calling component 2. Yeah, remember what we had in the game of life when we looked at the code of point. Now let's make these two non-private and run the test just to force the compilation. The only bad thing about Kotlin is actually that the JVM has a huge boilerplate until it runs. That's why the build times are so slow.
And Christian, what about the compiled code? Is it bigger than Java, or is it comparable?
And when we look at the disassembly of our point2D class, we find that's the operators plus and range to the other range to neighbors. Just a moment. Hey, Siddharth? Yeah, I just switched them on. Thanks. Yeah, Siddharth just told me my speakers were muted. So yeah, speakers are on again now. So sorry if I didn't hear you.
Yeah, Christian, I had a question about the compiled code with Kotlin versus in Java. Is it the sizes are comparable, or is it much bigger?
The Kotlin code is bigger. Yeah.
All right.
But that is only if you make a direct comparison between an isolated class versus a corresponding isolated class. Then the Kotlin code is bigger. But in the overall code size, my experience is that the Kotlin code, not only the source code, but also the jar files, is smaller because the instruments of composition in Kotlin are more powerful, through which you gain more reuse of code. And that means if your code base exceeds a certain threshold size, and production code bases very quickly reach that point, in the end, your Kotlin code base actually is smaller than the Java code base. Yeah. But thanks for the question. It's an important question. My experience is only isolated classes. Kotlin code is bigger. As soon as you have a real-world project where all the composition of the different parts of your project play a role, Kotlin code is smaller. Now, for example, you don't need builders. You get the builders for free. And that's something you don't see if you just compare two classes. But when you then compare the entire code base of equivalent code, then you see, oh, we don't have the builders, yeah, and we have delegates and a few more things that we don't talk about today. And these things just overall reduce your code size. And I'll happily trade the invisible JVM bytecode boilerplate of Kotlin for the overall reduction in code size and gain in maintainability.
Yeah, makes sense. Thanks.
So here we have component 1 and component 2. Yeah? The component 1 and component 2 are kind of aliases for X and Y. X and Y are the named things, and component 1 and component 2 are the positional things, and the positional things are used for the destructuring. So in case I would destructure my point, I don't have a good example to destructure a point, but I would have a lambda where I want to have X and Y separately. Instead of having P and then accessing P.x and P.y, I could just destructure it to directly X and Y. Yeah, so that's component 1 and component 2 the invisible workers in the background to enable destructuring. And you can destructure with the brackets, yeah. Declaring two parameters and declaring a destructured pair is different. You use the brackets, the parentheses to destructure. Without parentheses, you don't have destructuring. With parentheses, you have. And that allows you to combine. That's destructuring. Okay, default arguments, we had this. Named arguments, var args work slightly different. You have the var args keyword. Let's look into an example. So one thing that you need to know is if you want to pass on var args or erase as var args, you need the spread operator. If you're a Python programmer, you know this. Then it looks familiar to you. That's the spread operator. And the other thing is how to declare var args. Well, this is how you declare var args in Kotlin. You have the var args keyword. Yeah, and that's that. Nested functions, you're allowed to declare functions inside functions. Hooray. I find that quite useful during refactoring. I don't use it for my proper production code, but I use it during refactoring. When I have very large functions in legacy code, hundreds of lines of code, then sometimes I say, okay, it makes sense to first convert it to Kotlin and then refactor, because I have more power in Kotlin. Yeah. Yeah. So therefore, I think we are at the end of today's session. I hope it was useful. I hope you liked it. If any questions?
Yeah, are there any questions? I think there's one question that someone has asked around coroutines. Do you want to maybe briefly touch upon it? The reason why I asked is something we started a little late today, so you know you can probably complete the 3 hours.
For coroutines, I have to bluntly admit that I haven't used them yet. Yeah,
Oh.
so I actually can't tell you about them. I would assume that they work very similar to Go routines, but I haven't looked into their implementation. I haven't looked into the details. So other than they exist, I can't tell you anything about them. But I know that they're an important, interesting topic. Maybe we can have a future session purely on Kotlin Go coroutines.
Yeah, that's definitely a good idea. Any, to the participants, any other questions that you have about the session? Any questions? Can you suggest any materials on coroutines?
Yeah, the main material really is just the Kotlin reference. I found the Kotlin reference so well written. I don't remember using Stack Overflow for Kotlin.
Mm-hmm.
Yeah, I'm not sure if I ever have used Stack Overflow for Kotlin. Because the reference written by JetBrains is really very good. And what I feel about Kotlin is you can really feel love in the language and the passion of the language creators, the intention of making the language a pleasure to use. That's something I really miss when I look at Java. It's something I felt in Java at the beginning, and then after Java 1.5, I felt it going away. And I have refound that passion for making a language as useful for its users as possible coming up again in Kotlin. And it's something that if you're a JetBrains IDE user, if you use PyCharm or IntelliJ IDEA or so, you can already feel that passion for developers in the IDEs, and you feel that passion again in the language. So maybe as the concluding thing, I should show you a side-by-side comparison of Kotlin and Java code that are equivalent. Maybe that would be the best conclusion. Now I'm just gonna show you side by side. These two classes are totally equivalent. And see what difference it makes going from
The readability is so much
Java.
in Kotlin.
Yeah.
It's so much easier.
Yes. To the fact that Kotlin rewards you for writing clean code. In the last step, Java lets you down. In the last step, in Java, you get the feeling like, why have I done this? I now have all these one-line expressions, but they all consume 4 lines on my screen. And you start doubting your efforts of writing clean code. In Kotlin, it's the opposite. Kotlin says, you're writing clean code. Here, I have the cream, the icing on your cake of clean code. Your functions can be just 1 line. And then your classes become so compact that you achieve a new level of readability. And that's one of the many things to love about Kotlin. Okay. Tanai say something very nice. And hi, Tanai. Nice to see you on the call. JetBrains are so passionate about Kotlin that they even have a plugin for Eclipse. Yeah. I didn't know that. I don't like Eclipse that much. Yeah. So yeah, thanks a lot for joining the session. If you're interested to keep in touch, I'm on social media. My name is unique. You can find me on Twitter, on LinkedIn, on Facebook, also on a few others, although I don't use them that much, like Instagram, Pinterest, Flickr, Tumblr. You can also send me an email. If you run your own local meetup community, like if you're from Chennai or some other city or so, or even from another country, and you would like to invite me for a meetup, I speak pro bono, like most of the speakers. So I'm not charging for sessions like this. I do it for the love of the community. And so if you want to invite me to your own meetup group or something like that, just go ahead, reach out, discuss with me on Twitter, contradict me where I'm wrong. That's the thing where I learn most, if people contradict me. So it's something I just really love and enjoy. Yeah, have a great time with Kotlin in your future. And
Again, thank you. It has been a wonderful session, and we've already been receiving feedback on the chat on how they really enjoyed. All the participants enjoyed the session. I thank all the participants. I know it's difficult to take time off on a Saturday morning, but I'm so glad you all did. We are thankful to you from here at Technogise. We have recorded this session. We will be putting this session up on our YouTube channel pretty soon, and we'll be informing each and every one of you about whenever we do that. You can share your feedback on the Meetup channel as well. You can recommend the Meetup to other friends and colleagues of yours as well. We will be having a similar session next month too, with a new topic. Yeah, till that time, thank you everyone again. It was it was a pleasure having you here. Christian, again, thank you as always. Your session has been wonderful.
And thank you, Mayank, for organizing the session and for doing such a good job also with the marketing of the session to give as many people the opportunity as possible. I know that it's quite an effort to on your side to do that, and very much appreciated for giving me the platform and the opportunity and for what you've done for the session. Thank you, Mayank.
Thanks. Thank you. Thanks a lot. Okay. Thanks, guys. We'll be closing the session now. Record.